Hello, good day and welcome. I'll be answering JAMB 2020 Physics Past Question 34. Light of frequency 6.0 times 10 raised power 14 Hz traveling in air is transmitted through glass of refractive index 1.5. Calculate the frequency of the light in the glass. A says 4 times 10 raised power 14 Hz, B 6.0 times 10 raised power 14 Hz, C 7.5 times 10 raised power 14 Hz, and D 9.0 times 10 raised power 14 Hz. Now, when a ray of light travels from air to glass, for instance, let's assume we have a glass like this, and it's the ray of light, let's assume this is normal, travels from air. This is air and this is glass. Now, because the light is traveling from a less density medium, which is the air, to a higher density medium, which is the glass, the light will be refracted towards the normal ray, which is called refraction. Refraction is defined as a change in direction or change in velocity of the light's wave. Now, because this light is refracted, because it passes from a less dense medium to a denser medium, which is the glass, now it will be refracted. Now, there are certain changes that occurs to this light. One, there will be a change in speed of the light. There will be a change in wavelength, and there will be a change in direction. But one thing will not change, and that is the frequency. The frequency of the light will never change, no matter the medium at which it crosses. So frequency remains the same. So no matter the refractive index of the glass, the frequency of the light will remain the same in the glass. And like we are given here, the frequency of the light is 6.0 times 10 raised power 14 Hz. So also it will be in the glass 6.0 times 10 raised power 14 Hz. Thank you, and you should subscribe to the channel for more videos and past questions.